So next, let us deal with distributed processing. How processors are distributed inside an exchange, we will discuss in more detail. So in our previous lecture, we have seen how processors are placed, or how the process architecture was made inside an stored program control exchange. So now let us deal with how these processors are distributed and how they are working and how they are coordinating all those things in more detail. So we know the reduction in cost of processing was brought about with the invention of microprocessors. So the cost required to process each and every call by the exchange was more when we were using separate computers, whereas in order to process a single call, the cost required by the exchange is somewhat reduced. Of course, it is to a maximum extent reduced with the invention of microprocessors. Of course, it is still reduced with the making use of distributed processing, and this enabled the control of switching systems to be decentralized. So what we previously, it was centralized one switching, we were using only one processor at the center, and we used to call it a central processor. And now we are using so many other processors which are performing other tasks as well as which are performing similar type of tasks, and we call such switching system to be a decentralized one, and this is made possible with the invention of microprocessor. So instead of all processing being performed by a central processor, so what we can do is certain routine tasks as well as particular functions. Routine tasks associated with part of the switching system, that is associated with the exchange, includes root switch detection and operation of concentrators. So we know the importance of concentrators. So we also deal with particular functions like line scanning, signaling. So generally line scanning is required when a exchange needs to know what are the servers or what are the trunks that are free at that particular time. So for every 1 second, so the exchange needs to scan all the lines or all the trunks that are going out from the exchange. This is about line scanning. And signaling we will discuss in more detail. So before establishing a call, so we need to deal with how signaling been made between exchange and the end user, or between exchanges also. So what we are doing is routine tasks as well as particular functions performed by an exchange are assigned to, or performed by a central processor are assigned to separate small processors. So we will make use of small processors inside an exchange, and those processors are made to look after routine tasks as well as different particular functions performed by an exchange or a central processor. So such processors, small processors which are used, are sometimes called regional processors. So those small processors are sometimes called as regional processors. So inside an exchange we will be having central processor as well as regional processors, and the central processor is required to direct the regional processors how they should operate, and also to perform the more complex tasks. So generally central processor is mainly doing complex tasks of the exchange, as well as it will be directing how these regional processors should operate. So it is very important to have message exchanges between a central processor and the regional processors. So messages implies control signals. So messages may be exchanged between central processor and regional processors over a bus or through an auxiliary switch. So over a bus we can have message exchanges between central and regional processors, and also we may use auxiliary switch also for transmission of control signals or messages, or through the main switching network. So over this switching network generally calls will be transferred. Of course sometimes we use control signals to be passed over the same switching network. So in the early SPC systems, fully centralized processing places a restriction on the amount of directly addressable memory. So we know when we were using centralized processing, we used to have a single memory component. So we need to address that memory, or from that we need to access that memory, so again and again, for performing different operations. So this was somewhat difficult to assess that particular single memory again and again when we are dealing with fully centralized processing, which was available before, that is in the early SPC system. But now with the help of distributed processing, this dimensioning problem, or the amount of common storage, was eliminated. So previously it was an issue, using a common storage was an issue, but nowadays the use of distributed microprocessors, and of course each regional processors or microprocessors, small distributed microprocessors, each are having their own extensive random access memory. So each and every processor will be having their own RAM, and they used to store data inside that RAM, and this eliminated what was the previous issue, that was dealing with central processor, that is centralized processing system. So with the help of distributed processing with their own RAM, so the issue which was there, that is with respect to a common storage accessing, was eliminated. So that limitation was removed. Since regional processors are relieving the central processor's tasks, that means they are reducing the tasks which central processor used to do, such as line scanning and digit reception, and also the complexity of its call processing software is reduced. So whatever the complexity that was involved in handling a call, that is call processing software, was also reduced. Previously all those operations were performed by a central processor only, but now regional processors are taking majority of the tasks. And also reliability is somewhat improved, as well as maintainability is also improved in our distributed processing systems. So as a result of data being stored at the regional processors, no processor requires access to data that is beyond its direct addressing capability. So since each and every regional processor is having their own memory locations, so they used to store data inside their memory locations, or these regional processors don't expect to access for another memory, or it may be this central memory which was available with the central processor. So these processors need not to go for another memory for accessing data, so they used to store their data inside their own local memory. So no processor requires access to data that is beyond its direct addressing capability. So this eliminated the need for frequent disk access. So previously we used to have frequent disk access, and this has been eliminated with the help of local memory of their own regional processors. And this increases the speed of call processing. So with the help of this, we may increase the call processing rate also. So speed of call processing is improved. However, we should make sure that copies of all software must be available inside the backing store. So each and every processor must be having the copies of all software inside their memory locations, and sometimes reloading of those software are necessary into their RAM if the contents of the memory becomes corrupted. Sometimes we may observe contents of the memory becoming corrupted. So sometimes in such scenario, the backing store should have the copies of all software that are used by a regional processor as well as central processor. So that is how a distributed processing inside an SPC exchange operates, or distributed processing processors must operate. So next, let us deal with how software available with an exchange plays an important role in establishing a call as well as the proper operation of the exchange. So let us deal with what are the softwares available or associated with an SPC exchange. So we know, like any digital computer, an exchange also of course exchange processors uses stored programs for processing input data and to provide required outputs. We know how a digital computer operates. So a digital computer will be having its own software. With the help of those software or the programs that are written into this computer, so depending upon what programs are stored inside the digital computer, so its operation will be decided. Of course, digital computer takes input as well as it produces output. See, in the same way, our SPC exchange processors also use the stored programs that are available inside its memory for processing input data to provide required results or outputs. So many different calls must be processed concurrently in real time. We know many calls are arriving for an SPC exchange at the same time, and the processor therefore performs successive tasks for one call along with those for other calls. So a processor is involved in performing many different tasks for a particular call as well as for all other calls also. So different calls must be processed by the single processor at the same time. So it is very important to decide how the processor should operate. So each time a processor returns to a call, it needs to determine its state. Of course, whether the state is state 0, state 1, state 2, all different states must be decided by the exchange implies the processor. So of course the processor decides its call states by reading data from memory. So we know memory will be available, so that memory will be having the details of different calls states. So the store areas that are assessed by the processor includes, so there are different memory locations available with an SPC exchange. So those different store areas assessed by the processor of our SPC exchange includes, first let us deal with the line store. So basically this line store has details or data about the termination. So there are line terminations, what are the class of service available with the end user, and what will be the status of the line, whether the line is busy or free, or whether it is parked. Parked means call on hold. So if the call is on hold, we cannot make a call for that particular person, that is called person. So this memory location, that is line store, will be having complete details of the end user, that is customer. Similarly, we will be having some other memory which is basically dealing with call record. These are the store areas we are dealing with, and in that particular we will be dealing with call record. So the data stored for each call include, so that is time of origin, at what time the call is originated for the system, and equipment number of line. So end user will be having his own equipment number, or the telephone will be having its own equipment number. So all the equipment numbers of end users must be available with the call record. Similarly, equipment number of other equipments, of course with respect to a particular exchange, what are the different equipments that are connected, and their equipment number must be available with the exchange. It is store areas. As I said, each application program deals with part of the system operation. So system has to operate, and that will be how the system should operate will be decided by the application program. And we know the operating system provides the required environment in which the application programs are going to run. So these application programs must run inside a particular operating system. So let us deal with what are the functions that are included with respect to application programs. So let us deal with what are the different functions that are associated with the application programs that are running inside an exchange. So first let us deal with control of timing. So an exchange must control the timing of the proper timing. So you should look for what are the timing associated with the establishment of the call. So to ensure that processes are executed at specific times as well as at periodically, so controlling of timing is required. Controlling of timing is required. Of course, to perform controlling of timing, we will write separate function in the form of application programs. So of course, we know processes are executing at particular times as and when call is arriving. Sometimes we need to perform certain operations. Example is alarm call. So initially we will define at what time the call should be made. So that is what alarm call is. Similarly, sometimes we need to perform certain operation or processes periodically, so that as we have seen, line scanning is being done periodically after every second or after every 0.5 seconds. Next, let us deal with scheduling. Of course, a processor or the exchange must perform scheduling operations also. So to ensure that processes are carried out with a predetermined order and timing, so scheduling is important. So processor must make sure at what way of one at what these tasks must be performed one after the other. So the order of the operations must be decided, and of course that is will be taken care by the help of scheduling, and also with respect to timing. And also the function includes interrupt handling. So when an interrupt occurs, so we should give priority for that particular interrupt. So to ensure that high priority processes are given precedence. So when high priority processes need processor, in such case we will provide processor for that particular program. So that is what interrupt handling is. We know how interrupts are used. Similarly, let us deal with interprocess communication. Of course, when two different processes are performing, so one processor output may be the input for the other processor or other process. So we need to facilitate communication between software processes, and also sometimes if necessary we need to provide communication between processes, two different processes. As we said, we will be having regional processors as well as central processors. Sometimes different regional processors may exchange data, or this regional processor may send data to central processor. So all those interprocessor or interprocess communications must be provided by the exchange. And also input output control is required, so to allow communication between processor and the system, it controls. So between processor and the end system, what the controlling is taking place, so communication should take place. Of course, the system is taking input as well as the system is providing outputs, and the system operation or the system control will be decided by the processor. And we have to deal with certain functions like storage management also. So to control the storage and accessing of exchange, and also to control or in order to assessing of customer and call data, we need storage management. So it is important to manage the storage of a particular exchange, because an exchange will be dealing with assessing of exchange implies, so one exchange will be communicating with the other exchange, also one exchange will be communicating with the end users, that is terminating users, that is customers, and also call data also must be taken care. So what are the data associated with the call must be stored inside the exchange, of course. So to deal with those things, storage management is a must for a particular exchange. So storage management, depending on with respect to storage management, we will write certain application programs. Similarly, we need to deal with, or an exchange must be dealing with human machine communication between end user and the exchange. Communication must take place. With respect to that, we will deal with certain application programs also in order to provide the protocols for communication between terminals, that means end user, call terminal, which is nothing but a human being, and his telephone, and the processor is also with the exchange. So need to provide a suitable protocols for communication taking place between human and the machine. So these are the different applications that an exchange must deal with. So for different applications, we will write application programs, and of course those application programs are running on a particular operating system. So we have seen how call processing is being made by the exchange. So in addition to call processing, a central processor performs many other administrative tasks. So those administrative tasks include database management, fault diagnosis, alarm processing, automatic testing of lines. This is what line scanning is about. Similarly, traffic recording. So at what time what will be the traffic, and what different time what will be the traffic, all those recording must be made by the exchange. Of course that will be taken care by the central processor. Similarly, changing customers facilities. Sometimes an exchange must be able to change the customer facilities. That is what basically deals with class of service. So exchange has the power to change the customer facilities. And directory number. Sometimes the exchange need to change directory number also, and also changing routing. So an exchange must look, or the central processor must look into changing the routing path. So in which path the routing of calls must be made. So all those things will be taken care by the central processor. And also routing codes. So what are the different routing codes that are involved, that are related with routing, and the generation of exchange management statistics. So a central processor must be able to generate exchange management statistics, how the exchange is handling the calls. All those statistics must be generated by the central processor. So these different administrative tasks require a large amount of software. Of course, in order to perform these different tasks, we need a large amount of software. Of course, that is true. However, since they are performed infrequently, they use much less processing time than call processing. So all these operations are performed frequently, and of course they should use less processing time than the call processing. So we know an exchange or the central processor must handle calls also. That is what about call processing is. And also it has to perform all other administrative tasks. Generally all administrative tasks are frequently performed, and they should use less processing time than the call processing time required in establishing the call. So generally the software for an SPC switching system, that is SPC Exchange, is usually written with the help of high level language. So best example for high level language is CHILL, CHILL. So generally this is a high level language which is basically used by telecommunication systems, to write this software, program software. So a switching system is required to suitable for many different kinds of exchange. Of course, we know switching system is required by whether it is a local exchange, that is a small exchange, or a large exchange like tandem exchange or a trunk exchange or international exchange. Of course, the operation of switching system in whether it is small exchange or large exchange remains the same, similar to that of different exchanges switching system will operate. So many system functions, example basic call processing, are required for all of these different types of exchanges. So of course basic call processing remains the same for different calls. Please note that other functions are required in certain applications but not in other exchanges. So functions required by local exchange may not be the same what are the functions required by the trunk exchange or a tandem exchange. So that is what the idea is. Let us consider one example in which the provision of customer facilities is not required for a trunk or a international exchange. So what are the provisions, or that means what are the facilities provided for an end user, that is customer. So all those details are not required in case of trunk exchange. So only those details, those facilities must be made available in local exchange, because local exchange will be connected to the end users. So those are the different functions that are required in certain applications. Only certain functions are required by certain exchanges, whereas certain functions are not required by the other exchanges. So the use of modern software enables a manufacturer to supply required functions for each exchange economically. Of course, we will make use of modular software. With the help of this modular software, we can provide required functions for different exchanges. Of course, please note that functions required by all exchanges, all types of exchanges are not same. You know that. So when we are building a software for a particular exchange, the first step that we have to perform is to select the appropriate program modules from a software library. So from the software library, so depending upon what software we have to build, we have to select the appropriate program modules. So an example is type of line termination and signaling system that we have to use for a particular exchange. So what is the type of line termination, whether the line termination is involved with telephone call, that is audio call or video call. So all those must be decided before we make the exchange into operation. Not only that, we have to deal with signaling system that we are using. Of course, different types of signaling systems are used. We will discuss what are the different signaling systems used in coming lectures. So it is when we are designing or when we are building software for a particular exchange, it is important to know what are the facilities that are required, and correspondingly we will select the appropriate program modules from the software library. Of course, the software library will be having different types of program modules. Suitable program module will be selected depending upon our application. So once we have selected suitable program module, so the next step is to link this generic software with data that differ from exchange to exchange. So we have to link this how the software takes data, how the software produces output data, how it takes input data. All those communication must be established. So that is what the next step is, to establish a link this generic software with the data that differ from exchange to exchange. So one exchange requires certain type of data and another exchange may require other type of data. So whether the data required by different exchanges are different, but the software associated with a particular exchange may not be the same. And of course, with respect to different software, so we have to communicate with the data that it is getting. Basically, this generic software is nothing but a application program that we load into our system, that is switching system. So it basically handles data from different exchanges. So the exchange dependent data include number of customer lines. So how many customer lines are connected for a particular exchange. So the data must be available with the exchange, and their class of service. So these customers have their own class of service. So all those details must be available with the exchange. And the junction quantities. Junction basically deals with trunks, number of trunks or the number of servers that are available with an exchange. So junction, what is the number of trunks? Junction quantities must be known for a particular exchange. And calling rate is required. So what is the calling rate a particular exchange is having during busy hour? All those things must be, all those data must be available with the exchange. And also the traffic loads. So what is the amount of traffic it is handling? So all those details must be available with an exchange. So that is what exchange dependent data is. And these different exchanges will be having their own data. All those data must be linked to the particular software. So that is what the next step that we have to deal with once we have built the software. So next, the result is, once we have done all those building the software, and as well as once we are dealing with the data that is applied or that is available, that the data that should be given for an exchange. So next we go for commissioning and servicing. So the result is the complete software build. So once we have done those two steps, the complete software will be built for a particular exchange, and now the switching system, that is the exchange, is ready for commissioning. So it is ready for operation and service for a particular end user in the network. So in our next lecture we will deal with overload control. Thank you.